This is Gary Railsback, and this PowerPoint is discussing the concepts in Salkind7e's book. We're going to be looking at Chapter 6, which the topics are validity and reliability. So the chapter is called Just the Truth, an Understanding of Reliability and Validity. So here's what we're going to be talking about, and hopefully you will learn by the end of this session. We're going to define and try to understand those two terms, reliability and validity. So your question may be, what's up with this measurement stuff? That's actually Salkind7e's question. It appears like it's an educational psychology course. But it's actually really important for DBA students who are going to use some kind of instrument. So the application of this information is for your dissertation if you choose to administer an assessment tool. So especially we're going to be looking at that on slide 23 and beyond. So the focus of the chapter is to understand the quality of tests being evaluated. We're going to be computing and interpreting various types of reliability coefficients and computing and interpreting various types of validity. So again, that question, what is this measurement stuff? We're going to be looking at the dependent variable, and I have a graphic in a minute, but the dependent variable is sometimes called your outcome. It's what you're trying to see, and we're not probably talking about some kind of an experiment here, but we're trying to determine whether any change has occurred as a function of the treatment. And, that treatment might be having employees go through a workshop from the Human Resources Department, sexual harassment, supervisor training, any of that could be a dependent variable. The independent variable is a variable that does not change, and as they say in here, it's the treatment. Or an independent variable could be something like demographics of the employee, something that doesn't change. So here's the graphic that I got from Alexander Aston, my statistics professor at UCLA. If that name sounds familiar, depending on if you're old school, you may remember the Addams Family, and there was a guy named John Aston who was the father. That's Alexander's brother. And John married oh my goodness, I can't remember who he married. But anyway, his stepson is Sean Astin, who you may have seen in some recent movies. Alexander Aston developed this graphic to help us visually see what happens when we do a study on an environment. So on the left side are the inputs. They don't change, and it's what your people arrive with: gender, IQ, personality, whatever. And then at the top of the graphic, the environment is anything the participants experience in the study. In an experimental design, we would call that treatment, but it doesn't have to be like a medical treatment. As I said, it could be attending a workshop. And then on the right side is the output. So what are you trying to change? Their attitudes about some kind of new work procedure or whatever. Anyway, that's the graphic. So it's called the IEO model. So reliability, it means that the measure is consistent in measuring what it's designed to measure. So reliability is not the same as validity. It does not reflect whether you're measuring what you want to. Oftentimes, on an assessment or survey, you're looking for results to be consistent and not change between readings. Validity means that the test, the scale, the survey, the instrument measure what you're really wanting to know. For example, an IQ test is used to determine if a child or adolescent has an intellectual disability. Well, it needs to be valid. It needs to be measuring intellectual ability. And it needs to be reliable so that if you gave it over time or you had different groups, it would be consistent. Test scores. Another thing it talks about in the chapter is the difference between an observed score, what you actually get on a test. So let's say you get a score of 89 or maybe 65. The true score is 100% accurate reflection of what you really know. And so we need to recognize that rarely are the observed, that 89 or 65%, the true score. So you probably know more than you got on the test. But those are differences that we need to keep in mind. The observed score equals the true score plus the error score. So the error score is the difference between the observed and the true. Sources of error are conditions that impact the obtained score rather than the quality of the trait being measured. So in testing situations, whether the temperature of the room was too hot or too cold, that might affect the test score. So there's a number of types of reliability. One is test, retest reliability. So if you take a group of students and you gave them a test, and then a week or a month later you gave them the same one, it should be fairly constant. Parallel forms is another way that we look at reliability, and that's when you want to know if different forms of a test are reliable or equivalent. For example, the standardized test that's used high school graduates or to get into grad programs, the SAT, ACT, or GRE, have multiple forms. And one reason those organizations might use them is because they want to make sure that, like the ACT, for instance, it's given to high school kids all over the country on different dates. And they can see if it has similar results. Another example is to have two forms, and I did this when I was teaching undergrads. I'd have a form A and B. It'd be the same items. They might be in different order, or they might be different questions, but they're measuring the same content. Internal consistency reliability. That's what you want to know if the items on the test assess one and only one dimension. So is it only looking at intelligence and not behavior or something else? Another very common one is inter-rater reliability. So when you want to know whether there is consistency in the rating, this is one example I can think of is comprehensive exams. When I took mine in my doctoral program, they were rated by several different faculty. And if one faculty member went through the different questions and rated it on a scale of 1 to 5 as being all 5s, and then somebody else comes along and there's a score of 3 or 4, a 2, and a 5, those would not be reliable. And so you want to make sure that when you have humans or even computers doing the grading, that there's inter-rater reliability. So the question, how big is big? When interpreting reliability coefficients, you want two things. The reliability coefficient to be positive and not negative, and to be as large as possible. So it's going to be somewhere between 0.00 and 1.0. So it might be 0.7, might be 0.5, but you wanted to be on the bigger side. To establish reliability, you need to have standardized instructions. You need to make sure that if a test like the SAT is given, that every teacher who's in the front of the room describing it gives the same information. You want to increase the number of items. You want to delete unclear items, make the test neither too easy nor too hard, and you want to reduce the effects of external distractions. Validity. Whoa, what is the truth? A valid test is one that measures what it's supposed to measure. And the three most commonly used types of validity are content validity, criterion validity, and construct validity. So we'll go through those individually. Content validity is making sure that what the test is measuring is really consistent of what should be there. And I'll talk about that a little bit more in a minute. The second one, criterion validity, it's either predicting or it's concurrent. And so like the SAT, GRE, all those are trying to predict who's going to do well in college or a graduate program. And the construct validity has to do with how it's put together, how it's constructed. So with content validity, when you want to know whether a sample of items truly reflects an entire universe of items on a certain topic, how do you establish that? One is you might have a panel of experts. So if you're wanting to measure content, the example I came up with here is what beginning accountants need to know. So when they finish a BA program, what is the amount of knowledge they should know? So you'd get a bunch of practicing accountants. Do the items represent all possible items? And how comprehensive does that need to be? And how well does the number of items reflect what was taught? So if the test is supposed to be on what somebody learned in college, we need to make sure that it was actually taught. If it wasn't, then it's not very helpful. Criterion validity, are the test scores systematically related to other criteria that indicate the test taker is competent in a certain area? Concurrent criterion validity, how well a test outcome is consistent with the criterion that exists in the present. And then we already talked about predictive, how consistent a test outcome is with a criterion that occurs in the future. So let's say you take the SAT or ACT and you finish high school and it's supposed to predict how well you're going to do in college. Well, it can predict some things, but it doesn't predict motivation or getting up out of bed and going to class or even going to bed on time. So there's a number of things that we need to think about when we're doing that predictive criterion. The construct validity, how well a test reflects an underlying idea such as intelligence or aggression. Most interesting, most difficult source of validity to establish. You want your construct to correlate with related behaviors and not to correlate with behaviors that are not related. In a minute, we'll talk about the attention deficit disorder or intellectual disabilities. So if you give a test to somebody to determine do they have a reading disability, a learning disability, or whatever, you want to make sure it correlates with those behaviors and not other things. And if you can't establish validity, what do you do? If your test does not measure what you want it to, you'll probably have to rewrite it. What you'd want to do is consult a content expert, examine the criterion you've selected, and look at the theoretical rationale that underlies the test. Validity and reliability. So on a test, it can be reliable, but not valid. In other words, an IQ test, you get the same range of scores, but it doesn't measure intelligence. A test cannot be valid unless it's reliable, because if a test does not do what it's supposed to do, then it has to do it consistently to work. So again, let's say we take an IQ test and we give it to somebody who we think maybe has intellectual disability. In the old days, we used to call that mental retardation. If the test said they're not mentally retarded, and then another time we gave them another version of that test, and they were, then it would not be reliable. And so then, therefore, the test cannot be valid. Here's a couple of examples from the real world stats. Assessment of attention deficit hyperactivity disorder, or ADHD. Often this diagnosis is based on the subjectivity of symptoms and reports of parents and teachers. So that may not be, that self-report or the report by others may not be valid. Nathaniel Zelnick and his colleagues looked at scores from the test of variables of attention in 230 children who were referred to their ADHD clinic. Among the 179 children that were diagnosed ADHD, and that was their criterion group, the test of variables of attention, that's the name of the test they were given, was suggestive of ADHD in 163 participants, or 91% sensitivity. But it was also suggestive for ADHD in 78% of the children without ADHD. So it's not just reliable enough to measure accurately and to discriminate between the two groups. So the problem with that one was that the percentage of students that were not identified ADHD was too high. Okay, so again, let's go back to that original question. What's the measurement stuff doing here? Almost any use of statistics revolves around some outcome being measured. So for example, the survey you took in week 1, that SATS, the survey of attitudes towards statistics, has been determined to be both reliable and valid. If it wasn't reliable, it would say your attitude was, let's say, frightened in one administration, and then a week later, enthusiastic about statistics. How would that help you if it's not reliable? Just as you read basic stats to make sense of lots of data, you need basic measurement information to make sure when you're looking at behaviors, test scores, rankings, whatever. Okay, so let's get down to the practical element. For your dissertation, let's say you're going to want to use a survey or an assessment, might be called an instrument. So this is from a student in the George Fox DBA program. I'm on his committee. One of the assessments he wanted to use is called Gauging Readiness for Organizational Change. It was developed by Holt and several other people. Now, they have developed validity and reliability for this instrument. So if you want to modify that instrument, it's no longer valid or reliable. And so you would need to compute those again. Otherwise, you're measuring it on an instrument that you don't know anything about. Another example, a lot of people like to do things in organizational culture, and this is an instrument I used in a class on organizational behavior several years ago. I think it's a great instrument. It can be found in the book that I've referenced. It has been determined to be valid and reliable. But let's say you want to make some modifications on that instrument to maybe fit your organization. Maybe you don't think it's measuring exactly what you want. So if you modify it, it's no longer valid and reliable. The other thing you need to consider is most instruments are probably copyrighted, and so you'd need to write the instructor, as I did with the statistical survey. My third example is the multi-factor leadership questionnaire. It's been used extensively since it was first developed by Avolio and Bass. It's called the MLQ. It shows strong evidence for validity, construct validity, and reliability. Again, if you make changes, it's no longer valid and reliable. So as we close out this chapter, remember to look at the practice questions at the end of Chapter 6. There's the student study guide on the publisher's website.